We now introduce the notation known as scientific notation. That's where we have a number a, whose absolute value is between 1 and 10, times 10 to the n, where n is an integer. Scientific notation is used as a way to conveniently work with very large or very small numbers. Imagine you want to multiply a 37-digit number and a 43-digit number. In decimal notation, this would be messy and error-prone. In scientific notation, it can be quite easy. So let's consider 9.1 times 10 to the third. Well, 10 to the third is equal to 1,000. So 9.1 times 1,000 would be 9.1 times 1,000, which would give us 9,100. We can also think about this using the fact that we use a base 10 number system. So each time we multiply by 10, we effectively move the decimal one place. Multiplying by 10 to the negative 3 is like multiplying 9.1 by 10 3 times. So move the decimal 3 places. Notice the decimal started off between the 9 and the 1. If we move it 3 places, 1, 2, 3, it ends up right here at the end, which is where it's placed when we don't actually see a decimal in the number. Now consider 9.1 times 10 to the negative 3. Well, recall that 10 to the negative 3 is the same as 1 over 10 cubed, so this would be like 1 over 1,000. So 9.1 times 1 over 1,000 is actually a very small number. Keep in mind, each time we multiply 9.1 times a power of 10, we're moving that decimal place. So for really, in this case, dividing by 1,000, we're still moving the decimal 3 places, but we're moving it the other direction. So if we have 9, 1, and the decimal starts between the 9 and the 1, and we move 3 places, 1, 2, 3, then we get zeros in front, and then we put our decimal. So 9.1 times 10 to the negative 3 is 0.0091. Students often try to memorize which direction to move the decimal when converting from scientific notation to decimal notation. It is better to understand than to memorize. If we multiply 1.1 times 10 to the 7th, 10 to the 7 is a big number. So do we expect the answer to be bigger or smaller than 1.1? Well, if we multiply 1.1 times a big number, we expect the number to be bigger than we started with. So that indicates to us which direction we should move the decimal place. So we start off with 1, 1. The decimal place was here in between the ones, and now we're going to move it 7 places. So 1, 2, 3, 4, 5, 6, 7. And then we just fill it in with zeros. And there we get 11 million. Now consider 1.1 times 10 to the negative 7. 10 to the negative 7 is a very, very small number. So when we multiply it times 1.1, we expect to get a number that's smaller than 1.1. So when you're counting off the 7 decimal places that you move, count the direction that's going to make 1.1 smaller. So we've got our 1 and our 1. The decimal was in between these two ones. Now we're going to move 7 spaces. 1, 2, 3, 4, 5, 6, 7. And then we fill in with zeros and a decimal place.